Okay, thank you everybody for turning up this morning. I believe this is the first presentation in this theatre today, so thank you for arriving nice and early. So that means I've got you nice and fresh. I've got a presentation here which I've tried not to make it too nerdy, but there is a little bit of nerdiness in there, but I didn't want to overload you with it all really. So we'll start off nice and simple, and then we'll see how we get on. And I'm on the Tuscany Network stand 222 later on, so if you've got any questions you can come and speak to me after the talk. So let's start. Okay, so a little bit about us. Basically I'm from Tuscany Networks. We're a software, a solutions integrator that have been going for 14 years now, established in 1996, and we specialise in what Gartner called DDI. So Gartner launched a market scope report last year where they mentioned us as one of the managed service providers in this market space. So DDI has been around for years. It's just a new term that they've coined, so you might hear more and more of this term going forwards. But it's basically DNS, DHCP and IP address management. And we've built up quite a large portfolio of really large FTSE 100, FTSE 250 companies, banks, telecoms companies, service providers, all sorts of people. So we're real specialists in our area. We're really focused on this particular market. So start off nice and simple with what exactly DNS is. Now obviously everything on the network nowadays uses an IP address. And because humans aren't very good at remembering these IP addresses, we give everything a name. So those names are stored in the DNS, and DNS basically provides the translation from those names into an IP address. So you can think of it as a telephone directory for networks. And DNS is used throughout internal networks, like Active Directory for instance, and also obviously on the internet for finding websites. So if you imagine the internet without DNS, all those TV adverts you see, obviously it's very easy to go to www.orange.co.uk or directline.com, compare the meerkat, but if you didn't have DNS you'd have to use these IP addresses. So I mean I'd be tempted to challenge you to remember these particular IP addresses and come back to me after the presentation and tell me what they are, but you've got pens so you're probably scribbling them down right now, so no prizes, sorry. So DNS actually stands for the domain name system, and you have specific servers that run the DNS service. So you can have multiple servers on the network to provide resilience, because obviously if one of those DNS servers fails, you're going to stop looking things up, you won't be able to find anything. So it's very simple. You basically have a very simple query response type mechanism where a client will be trying to look up a name of a web server, for instance. Query goes to the DNS server, response comes back from that DNS server containing the IP address. So dead easy. Now one of the problems with DNS is there's been very little security. DNS actually kind of grew up over the early 80s and was launched kind of around about 1984, 1985. So it's 25-year-old technology now, and there hasn't been any major changes to it. So messages are sent in plain text, basically. It was used, invented in the day when people used to trust each other implicitly. But the protocol itself is very easy to spoof. And over the years, there's been numerous attacks reported that have been DNS related. Denial of service is quite a common one. There's this thing called WPAD spoofing, where basically you can take control of someone's proxy server. And the one that I'm going to be talking about is cache poisoning. And cache poisoning has been endemic in DNS ever since its inception, and it's still with us today. So cache poisoning is really about getting malicious data into your DNS server and getting that DNS server to serve that information out to legitimate users. Now traditionally it's been quite easy to do this. There were some well-publicised attacks back in the 97 was really the main attack when something happened. So a bunch of patches have been released over the years to try and resolve this problem and make it harder and harder. But ultimately, cache poisoning attacks can still happen. They're quite difficult to do, but at the end of the day, it can still be done. So we talk a little bit about the technology behind DNS, and then I'll start talking about how a cache poisoning attack can happen. It's important to understand that every DNS transaction has a unique transaction ID. A transaction ID is basically a 16-bit number. So you've got 65,536 possible values for this number. Now what happens is when a DNS response is sent from your client or from a server trying to resolve a name, it stamps the query with a random transaction ID. And the idea is that it can match the response that comes back with the same transaction ID. So if you think of a large ISP sending thousands and thousands of queries, they'll all have different transaction IDs. And when all the responses come back in, it can match each response with the query that was sent. Now, if you can predict these transaction IDs, you could effectively spoof a response with a matching transaction ID. So we look at how transaction IDs work normally. We've got a user down the bottom here, just trying to resolve a normal website. So he sends a query to his local DNS server, and you'll see it's stamped with a transaction ID. Okay. So this is just a random number. So the local DNS server will go off and try and resolve that host name. So in this case, the user's trying to look up bigbank.com. So his local DNS server sends that query out onto the internet. The DNS server itself uses another transaction ID. And you see the response that comes back. And you'll see that in this case, the transaction IDs match. So the DNS server accepts it as being valid. It'll carry on doing the resolution process, querying other DNS servers, using transaction IDs as it goes. Each time transaction ID comes back, it matches. This is in the real world, when everything's working fine. That response that came back from the bank's DNS server, in this case, gets cached. So it means that next time, this DNS server can answer locally. It doesn't have to do all the resolution. Finally, the response is sent back to the client, and again, you can see the transaction IDs match. So everything's all hunky-dory here. Now the problem is that these transaction IDs aren't necessarily that random. Now historically there's been quite a few problems with the generation of these transaction IDs. And there's a guy called Amit Klein at Trusteer who found that the random number generator that's used to generate these transaction IDs was actually quite poor. So he found that if the current transaction ID was even, then the next one could be one of only 10 possible values. So that if you were looking at these queries that were coming in and you saw the sequence of transaction IDs, it would be possible to work out what the next one was going to be. Microsoft had similar problems as well on the DNS server. So basically, if you can sniff a few of these DNS packets, you can predict what the next transaction ID is going to be and spoof a response into the DNS server and basically what they call poison the cache. So one of the things you can do to do this is to basically send an email. So we've got bad guy down here. Just sends an email to a non-existent email address at the bank he's trying to poison. So there's the bank over here. So he's using his mail server to send an email. The email gets forwarded onto the bank's mail server. Now the bank mail server doesn't know who this user is, so it needs to bounce the email back. It needs to bounce it back to bad guy. So what the bank's going to do is it's going to use his own DNS server to look that up. So he's going to look up this mail server down here. So he goes off to the internet, tries to look up smtp.badguy.com. That doesn't know, so he's basically get a referral back to bad guy's DNS server. Okay, so now this DNS server is under the control of our bad guy here. And we just look at the transaction ID. And we can do this multiple times. Now we don't really care about the reply, but we just want to sniff that transaction ID each time.